Hello guys, my name is Kirtan Joshi.
And I am Ajit Kumar.
Today we are presenting a slide on the big data and how this giant company handle a big data. So, on a daily basis, we use YouTube, Instagram, Google, and we all use, and we don't see many lagging experience. Like these companies are handling them backend servers on a good manner. Like we all use Google Maps also, and we also see our live streams. We also play online games like Free Fire, PUBG, and like that. But we don't have a lagging experience if we have a high internet speed. So how this company handling a big amount of data like that? Google gets over a 3.5 billion searches a daily. WhatsApp user also exchange up to 65 billion messages daily. Facebook generate 4 petabyte of data per day. Google handle over 25 zettabyte GB of data daily. But still, they provide good services to us. So how this company handle this data? The question is this. My topic is big data and how the big data is handled. And these slides are prepared by Kirtan and Arshit.
So there are three characteristics of big data. First, volume. Second, velocity. Third, variety. In volume, we have to need a large, huge amount of data, just like Instagram and YouTube have large amount of data. It's megabyte to gigabyte. In velocity, when we have prepared a video on YouTube or Instagram, then we have to need 4K resolution to stream this video. So in this scenario, we have to need large amount of data, and this category belong to velocity. In variety, we have to need text, video, audio, image, structure, and unstructured data in this category. So here, velocity involves high data throughout and often real-time data processing requirement. And variety encompasses different types of data that needs to be aggregated for storing, querying, and processing. And volume of data generated by current and emerging application is emerged. So there are many types of big data.
As we know, we have a structured data, we have a unstructured data, we also have a geospatial data. Like you all use Google Maps, so for that we need a geospatial data where your coordinates are located and the whole maps and the whole geolocations are stored in a way. We have a machine or operational logging data. Like we all use smartphones and we have a clickbait data. Then how we handle that type of data? We also have some open source data. Like we have to train our LLMs, our AI models. So that how that data is stored, and we also have some semi-structured data. So the question is how this data is handled. So first we think about a SQL database, but SQL database is not efficient to store a huge amount of data because it is not designed to handle a massive volume and a variety and a velocity of a data. As my friend told to you about the velocity and the variety, like if we thought about an example, then Facebook have a long video, a short video, picture, and some GIFs also, and also have some text feature. So there's a lot of variety in this data, but SQL database is unable to handle this variety. Also, if we take an example of a PUBG, it needs a low ping, so high data transfer speed and how throughout uh, of data. So in that case, SQL database will not work efficiently. So then, what is the solution to store as a huge amount of data? So the solution is NoSQL. And NoSQL is the one of the famous data structure for big data in current time. So NoSQL database is to classify into five type of data model: key value stores, column family stores, document stores, graph database, and new SQL. And new SQL databases are just a newborn baby. It's just, but still performing efficiently on a big data. And partitioning helps to make the distributed system like if we think we have a lot of data and if we divide that data in small chunks, then we can do a processing in efficient. So the partitioning is just like, and we also have a consistent hashing. Before learning about consistent hashing, I I am telling that this big companies uses consistent hashing to perform a huge amount of data in a efficient way. Like we all know about Discord and Amazon, AWS, Cassandra, Akai, and DynamoDB. These are huge data companies, but still they use a simple technique called consistent hashing to perform to handle a huge amount of data. So what is consistent hashing? First, we divide the data in small parts on a servers. Uh, and we divide that data by some hashing function. So if we have a lot of data and we divide by hashing function on different servers. Here we have a 4 servers, so we did a four module of 4. Now, what if one server get disconnected or not working? Then what we do? Then all the data will resampled and remapped to the servers. So that is a huge task because remapping will cost too huge amount of money to the company, and that will not come to the company's policy. So so researchers created another way called consistent hashing. In consistent hashing, like S0 is our server, S1 is server, S2 is server, S3 is server. These are our server, and K0 is our objects. K1 is object, K2 is object, K3 is object. These all are our objects, and we do in clockwise fashion. We do a mapping like K0 will map to the S0, K1 will map to the S1, K2 will map to the S2, K3 will map to the S3. So this is just a consistent relation. Now what will happen if a new server is added, like S4 is added? So now K0 will not map to the S0, but it will map to the S4. But other keys are remain same. So like K1 will still map to the S1, K2 is still map to the S2, K3 is still map to the S3. So we just have to map only, we have wrongly mapped only one key. So it save a lot of time and efforts of a company. So with simple hashing, we have to remap all the server to the key. But in consistent hashing, we just have to change few key server pair and instead of whole. So now, what if a server is get deleted? Then K1 will also connected to S2. It's simple. But what if a server and objects are unevenly distributed? Then the challenge occurs because there is no data between S2 and S3, there is no data between S0 and S1, and there is a huge amount of data between S2 and S4, S1. So that is a big challenge. Then let's see how will we handle this. So there is a concept of virtual nodes. In virtual nodes, we create some virtual nodes on our ring, and we distribute our servers on that. Like uh, S0 1, S0 2, S0 3 is virtual nodes of server 1, and the S1 underscore 1, S1 underscore 0, S1 underscore 2 is the virtual nodes of server 1. So we map like this. So, uh, interactive web and online gaming require low latency read and write. Gaining real-time behavior insights from a user mobile activity is also a huge amount of task. Percentage of writes, there is a fact that percentage of write increased from 10% in 2010 and now it's a 50% in 2012. So you can think what is the percentage gain in 2024. It will be too huge, and the further increase in write heavy workloads expect indicating the evolving nature of data processing requirement. And we all know that Google have a lot of work in pre-processing. Google do that. So in that also Google uses consistent hashing to provide an immense data on their servers. And also we all know about that the AI boom is happening. So AI need a lot of data. So in future, companies are trying to store a huge amount of data, and there is an hypothesis that on year 2030, till year 2030, the AI will learn all the data. Then AI will not remain a single amount of data on internet to learn. So but still uh, but there is another hypothesis that the internet is huge. So in the current time of AI, we all need the data. So how will we handling the so we have learned in this slide that how this company is handling this data. And this so NoSQL database and partitioning and consistent hashing all are the part of one. So to handle a real-time analytics of the big data. Thank you.